Hello all, and welcome to Explained with Dylan. Today, I'm going to upload my video to the correct YouTube channel, because multiple times in a row now, I have uploaded these videos to Sports with Dylan, which makes it very confusing until finally I realized that I uploaded it to the wrong channel, have to take it down, and upload it to Explained with Dylan. But, I am not going to do that this time, I hope. Today, I'm going to be talking about my favorite source of electricity. Nuclear fusion, which doesn't technically exist yet. Before I can explain what nuclear fusion is, I first have to explain what nuclear fission is. The nuclear power you all know and love today. And for some reason, they decided to choose the two closest words in the English language to describe two completely different types of nuclear power. Because they love making things complicated for everyone else. Who is they? I have no idea. Anyways, nuclear fission works when a neutron collides with a uranium atom and splits it, which produces quite a bit of energy. This happens over and over and over and over and over again, and that produces nuclear energy. Nuclear fusion, on the other hand, works the exact same way the sun and all other stars work. They take hydrogen nuclei and merge them together. They squish them together, which also produces tons and tons of energy. In fact, it is more efficient than normal nuclear energy. So, here is why nuclear fusion is by far the best way to produce electricity and energy as a whole. So, nuclear fission, for starters, produces quite a bit of radioactive material, which has to be stored away for thousands to hundreds of thousands of years. Meanwhile, nuclear fusion produces little to no radioactive material, and it goes away in a couple centuries, which sounds like a lot, but on the scale of nuclear stuff, then it's really not that much. I'm sure you have all heard of the Fukushima and Chernobyl nuclear disasters, or at least one of them. But that can't happen with nuclear fusion because it is so little radioactivity. Besides, these elements are easy to garner and they're not originally radioactive. Hydrogen, helium, unlike uranium, which is very, very radioactive. So now that we've covered why nuclear fusion is better than nuclear fission, I can now talk about why it's better than every single other source of electricity. So for starters, it does not pollute like fossil fuels such as natural gas, coal, and oil. Which means that it's way better for the environment, as is nuclear fission. Although people tend to get scared of the word nuclear, especially nuclear fission, as mentioned in the disasters before, but nuclear fusion is perfectly safe and perfectly fine for the environment. Even the cleanest sources of electricity, the most renewable energy, still does something to the environment, and it needs to rely on something. Solar needs to rely on the sun. Windmills need to rely on wind. And hydrocurrent isn't great for the fish habitat, as well as the fact that people complain about birds and windmills, which is iffy, but all in all, none of those are perfect for the environment. Nothing is, or so you think. But nuclear fusion is by far the closest we can get to being perfect for the environment. It is minimal damage. You don't have to destruct any habitats or tear down a bunch just to build a huge wind farm or solar farm. And you get perfectly good electricity from a clean source. The biggest problem with nuclear fusion is that it doesn't exist yet. But there is a project, ITER, International Thermonuclear Experimental Reactor, which is being worked on in France by 35 countries to create nuclear fusion. It is not a plant that they are currently planning to actually use to create electricity for the French grid. They're just trying to experiment. And if this one is successful, which it has made quite a bit of progress, they expect it to be fully functional by the end of 2025. Then other countries can start to build their own. Obviously, this is going to cost quite a bit of money, and I suspect, obviously, the first ones to jump to it are going to be Western Europe, Canada, and the States. The rest of the world might be farther behind, especially many of the third world countries that just don't have the money to create all new sources of electricity, because the problem being is that currently coal and natural gas are significantly cheaper to get than building multiple nuclear fusion power plants, because it's a completely new technology and it is costing billions of dollars. But hopefully that can change soon. If countries find out ways to properly develop nuclear fusion, then slowly the price will go down, meaning that those third world countries will slowly be able to invest in nuclear fusion as well. I do not think it would be wise to have nuclear fusion as the sole source of energy. You need variety. You can't rely on just one thing providing everyone energy in the world. But I do think nuclear fusion should support the majority of electrical grids by, call it 2050. Sure, you can have solar panels and wind farms and hydroelectricity that are producing quite a bit of power as well, but the main focus should be nuclear fusion. But we've got a ways to go. I'll make a video on this in 3, 4, 5, 6 years once ITER is fully functional and that nuclear fusion is starting to be developed around the world. I'll talk a bit more about this and how it's being developed, but that's a couple years down the road. For now, we just have to sit tight and wait for the best source of electricity to come.